Okay. Now we are going to look at chapter 3. Now I just posted assignment for chapter 3 through chapter 6. That means I've posted assignment for chapter 3, 4, 5, and 6 on the author. Now the due date for the others assignments, which is assignment for chapter 4, 5, and 6, I have not put out the due date yet. However, I have set the due date for assignment of chapter 3, the end of next week. That means next Saturday, not the coming Saturday, but next Saturday. So you have about 2 weeks lah to do your assignment 3. Now, assignment chapter 3 is just 2 questions. And then one question is regarding, let's look at the question, all right? Okay, one question is on flow over a broad crested wave, and question 2 is on flow through constricted channel. Okay, now I'm going to help you out. Before going further, I have checked your assignment 2. Apparently, I think two or three of you have not submitted your assignment 2. I believe I've given you ample of time to submit assignment 2. Now, bear in mind that your assignment is actually contributes to 5 marks of your total grade. Even 1 mark sometimes will change your grade. For example, if you get 79, you are lacking 1 mark, right, which will actually change your grade to A, that means 80. So you probably want to get as much as possible for your coursework. It does help, alright? So please bear in mind that a couple of you have not submitted your assignment 2. Please do so. Yeah, it's easier for me to mark all completed assignment at one time. Alright then. Now, what I'm going to do today is, I've shared the notes for chapter 3. So basically, you have the solution for all the exercises. So what I'm going to do is I'm going to help you with one of the questions for your assignment chapter 3. That means you are only left with one question to answer for your assignment 3, right? So this is a sort of tutorial to help you, right? Now, I'm going to help you with question 2, which is on flow through constricted channel, because I think I have not spent much time on this topic, so I'm going to help you out, alright? Now, you have these 2 questions, right? So I'm going to enlarge this a bit, okay? So I hope this is clear, alright. Now, you have these 2 questions, A and B for question 2, 2 parts, alright? Question A and B. Now for question A, right, it says an engineer. That means you guys, all of you are soon to be engineers, if you choose to lah, alright. If you choose to graduate and then become an entrepreneur, you still, I believe, the knowledge that you have gained here probably will be helpful at times, so right. Now let's assume you graduate and become an engineer. You are supposed to analyze flow in an open channel, right? It doesn't matter either it's an open drain or river, right? And then this channel is designed to be constricted. It could be, due to, when they propose some structure that constrict the width of the channel, right? So explain consequences due to the constriction. Now, what I'm expecting, right, from your answer is you need to explain, what would happen if, what is B max, what would happen if B2 is greater than B max, that means case 1. What would happen if B is equal to B max, and what would happen is if B2 is less than B max. Of course, it's case 3. So I would like your answer to actually you explain all these 3 cases, and of course I also want you to touch on, either this upstream flow is subcritical or supercritical. Basically, if you can draw out the, I don't mind if you don't want to draw the 6 cases or 3 cases, but three cases is in subcritical and the other one is when the upstream flow is supercritical. If you can draw out, then it's good. If you explain it, it is fine with me too, provided you give me formula when it is case 1. What will happen to your y1, y2, y3, case 2, y1, y2, y3, and case case 1, 2, and 3 lah, basically. I hope you still remember for both situation when flow over broad crested weir, you have H mean, and for flow through constricted channel, you have B max. Alright, so I hope you are still clear for case 1. Y1 equals to Y2, sorry, Y1 equals to Y3 equals to Y0, whereas Y2 is not YC for case 1. It's similar for all both of the situations. And then for case 2, when H is equal to H2 is equal to H mean, and when B2 is equal to B max, you are going to get critical flow that will start to occur lah. Alright, so in case 3, Y2, case 2 and case 3, Y2 will be critical depth, whereas for case 2, Y1 and Y3 is still the same as Y0, but for case 3, Y1 would be subcritical flow, that means higher than YC, and then Y3 would be supercritical state, that means the Y3 would be less than YC. Alright, I hope you are clear that. Now let's try to solve Q2B. Okay, I'm going to show how we are going to solve Q2B. Now, do you guys have this question with you already? Let me ask Shazwan. Is Shazwan there? Shazwan? How about Farahin? Are you still there, Farahin?
Yes, doctor.
Okay, Farahin, do you have this question with you already? Question assignment 3?
Not yet.
Okay, it's in order. I believe you guys are still in the mood of holiday, right? Am I right? Shahidah too? And all of you. Okay. No, don't feel embarrassed about it. I'm still in the mood of holiday too, actually. Okay, because when we tend to take leave too many days, right? We kind of become too complacent with it already. Okay. Darren.
Yes, doctor.
Okay. Are you okay? Or are you still in holiday mode?
Yes.
Holiday mode is it? Okay. All right, then let's take things slow, right? Okay. Now let's look at Q2B. If you don't have the question yet, okay, probably you want to snapshot this, okay, and put it on beside your, because I'm going to change the screen now. All right. what I'm going to do now, I'm going to show how to solve B1, 2, and 3. But let's look at this first. Water flowing uniformly. When it says flowing uniformly, that means the water depth given here is the depth of uniform flow. That means Y0 is 1.2 meter. Q is 18.6 cubic or cubic. All right. In a rectangular channel, so it is a rectangular channel, so you can find your YC using the formula of cubic root of Q squared over G. The Q is the discharge over unit width. You can use that already. You can use the simplified formula. And this is a case of constricted channel. Okay. Now, for case 1, right, for the first question, the question asks you calculate maximum channel width. That means the Bmax, that will not cause backwater upstream. That means the Y1 will still be maintained as Y0. So this would be case 2. We know that case 1 and case 2, Y1 will be equal to Y0. Okay, that means it will not increase. So what we are going to do here is, the question asks us basically to find Bmax. Right? So let's take a look, okay, how we are going to find Bmax here. Alright, let's look at okay. Kamarina dah nampak tak Kamarina? Can you look at the screen now? I think I'm going to change this. Awati, can you see the screen now, Awati?
Yes, Doctor.
Alright, great. Okay, now, I hope my writing is clear. Alright, let's look at this. The questions say, let us put the question side by side now. Because actually I also cannot, I need the value. 100. Yes. Now it's side by side. Okay, now, let's write out all the given values, right? So this is question Q2 B. Right? So we have Q2B. Now the given data would be, right? We have Q is equal to 18.6. What else? Why not? Because the flow is uniform flow, right? It's 1.2 meter. And then we have channel width. Now, in this case, right, I'm going to put it as B0 because this is the question. This is top view, right? Top view. So this is top view. So at location 2, right, the channel is going to be constricted. So I have here B0, right, and I have here B2. Again, this is B0. This is the location where we are going to have our Y1 here, Y2 here, and also Y3 here. Alright? So B0, the question goes first B0 as 8 meter. Alright? Okay. Now, that means whenever B2 being constricted, it will be less than 8 meter, the width. The width of B2 is going to be that less than 8 meter. Now, for the first part, alright, question asks us to find Bmax. Okay, let's draw out. Okay, I'm going to bring it here. Let's draw this out. I'm going to have here my EY curve. just trying to understand the question. Okay, it's a bit crooked, eh? Okay. Okay, it's supposed to be a smooth line, right? Okay, so I'm going to have, I don't know whether my y naught is here or here, alright? So, but I'm going to have my e naught here. Now for case 2, when B2 is equal to E max, I know this is my Q naught and this would give me E min naught and YC naught. Okay. For case 2, when my Q change, right, my E min actually will fall onto E naught. Okay, so this would actually give me E min B, and this is case 2, B max. I put here B max when B equals to B max. So this is Q when B is equal to B max. Okay, I have that. Alright. Now, can I get the value here? Now, look at this. I can actually find my B max if I know my Q. Now, how do I know my Q if I know my YC and also my E min? Okay? After I know my YC, I can get my Q and then I can actually find out what my B max is. Alright? So this tells a lot of details here. Alright? Now, therefore, the first clue would be, alright, to get this, alright, you get this point here. Alright? I actually know what is my E min when B equals to B2 equals to B max. My E min is actually equal to E naught. Alright, that means at case 2, right, my E min at this location is actually equal to E naught. Alright, at this location or when when there's no changes lah, when the B is B naught. Okay. Now, can I find E naught? Yes. Okay. The first step would be I need to find my E naught here, right? So E naught, okay, is Y naught plus Q squared over 2G Y naught squared. Now here's the thing, I'm going to put naught here. Alright? Now what is my Q naught? Okay, my Q naught is actually Q divided by V naught. Q is constant, but B, remember, B changed here. Alright, that means B2 is not equal to B naught. That means it has its own Q. When you want to read Y from at Y2, right, it should fall on this curve, but Y1 and Y3 is actually, it falls on this curve here. Alright, so just be careful the Q that you are using. Alright, if you are going to find Y using this curve, you need to utilize Q naught, but on this curve you need to utilize this Q here. Alright, Q2, basically. So Q naught is equal to Q is 18.6 and V naught is 8 meter. So 18.6 divided by 8. What is the answer? Anyone can tell me? Maybe, who's there? Are you guys there?
Yes, doctor.
What is it? Can you give me the answer?
$2.325.
2.325. Okay, thank you so much. So it's meter cube over second over meter. Or sometimes, right, this unit here, right, sometimes I can write like this. Okay, because meter cube I cancel with meter, right? I'm going to have meter square, alright? Meter square over meter, right? So I have that. Therefore, this is my Q naught, I forgot again. Okay, this is my Q naught. So E naught would be 1.2 plus 2.325 squared over 2 plus 9.81 times 1.2 squared. Okay, so what is my E naught here? Anyone can help me?
Satu point 391.
Okay, thank you. Now, thank you. You are Awatif, is it? Okay, thank you, Awatif. Now,
Doctor.
okay, look at this. Awatif she's giving me 4 significant number, alright? That means 1.391. So it's good because from day 1 of our class, right, I already recommended you to use 4. You know, if you are giving me answers, right, you should provide me, so answers in 4 significant numbers, right? And that's the first significant number. Now, after that, now we got E naught already. Okay. Now, sometimes, right, you also want to check whether your Y naught, right, is actually here or here. But it's okay then, alright? We can find YC naught later, alright? It doesn't matter. So after that, we can only get the E mean here. So let's say at location 2, right? At location 2, okay, my E mean when it's B max, right? B2 equals to B max, I'm just going to write. Now, by right, in your calculation, right, if you don't write this, it doesn't matter. As long as you understand, you can give me E mean 2. It doesn't matter. I know it's at location 2 because you are actually solving for this, this question, right? So I know the B2 is B max. It doesn't matter. You can give me E mean 2, alright? As long as, you get it correct. I purposely want to write here, that means B2 equals to B max because I just want you to understand further. That's it. And once you get it, it's fine. Right. So once you have, therefore, alright, we already know that at location 2, E mean for case 2, for case 2, E mean 2 would be equal to 1.391 as well. That means it's actually equal to this E naught if you're looking at this diagram here. Alright? So, therefore, can we find YC2? Yes. You know, at case 2, right? For case 2, your Y2 would be equal to YC2, because it's critical already. So, yes, once we have that, we can find this. What is the formula for YC2? Anyone can give me YC that relates with E mean? Anyone? What is YC that relates with E mean? It is 2 over 3.
2 over 3.
Yes, great, thank you. So it's 2 over 3 E mean B max lah, I'll put that. Okay, now therefore YC2 will be equal to 2 over 3 times 1.391 meter. So therefore YC2 is, what is the value here? What did you get here?
0.927.
927. Correct, 0.927, okay. Okay, 927. Who is this? Who is giving me the answer?
Haris, Doctor.
Haris, can you give me another number? Let's make it 4 significant number.
3. 3.
3. Okay, great. Thank you. Okay, thank you. So this will be 4 significant number, 0.92373. Thanks, Haris. Okay, now, once you have YC2, look at this. Just now, YC naught is, we didn't get YC naught 2, it's fine then. We get YC2, which is 0.9273. Actually, I want to plot this out. Earlier, our Y naught, right, is 1.2 meter. But I'm still not sure because this y.1 falls on this curve while this guy here falls on this curve, alright? Because it's on the different Q or different B. This one different B, right? So you have, I'm not sure whether this is sub or super, but I believe this should be subcritical lah, eh? Okay, because it's greater. But then it's fine, we can check later as well. Now once you have YC2, right, can you give me a formula that relates YC with Q? That means I wanted to find Q. What is the formula that relates? Just a second, I'm going to add somebody. Can anyone give me the formula? Remember this, we have YC equals to Q squared over G to the power of 1 over 3, right? Or cubic root, right? So that means in order for me to find Q, that means Q B max, I'm going to have, it is what? Square root of, or anyone?
Square root dy
G.
P2 kuasa 3.
Okay, thank you. Correct. Okay, so this is the formula. It comes from this. It's just rearranging the formula. So you have that. So I have QB max equals to, I could write here, times YC is 0.273 cubic power square. So could you give me the answer then? What is my QB max?
2.797.
797 meter cube over second over meter. Okay, we have this Q. Once you have this Q, can we find B? Yes, still remember this formula like Q is equal to Q over B. So we need to find this B max here. So what does it relates to? So we know that B max is equal to Q over QB max. So therefore, 18.6 divided by 2.797. So what is it?
Enam poin enam empat.
6.650.
Okay, thank you. Alright. So that's it. Simple as that, right? Vmax. You have Vmax already. Okay. You see, in chapter 3, right, I'm using this kind of EY curve, but from my previous classes, right, students always get confused between the problems of flow over broad crested weir. For flow over broad crested weir, when you are dealing with H-mean, right, the width of a channel is fixed. So you only have one EY curve. But then, when you are dealing with constricted channel, right, okay, you actually have, depending lah, okay, when it is only one reduced width, that means you are going to have two. Alright, for any changes of width, you are going to have different EY curve. Alright, so this is the first part. Okay, let's look at the second part. Alright, the second part. Okay, for second part, the question says, so now, okay, now you know that your B max is 6.65. Okay, now if you look at the second question, right, it says, what if the width is 4 meter? Okay, so B2 due to, due to unavoidable conditions, right? The width has to be set to 4 meter. So the question asks us to find Y1, Y2, and Y3. So these are unknown. So basically, the question asks what would happen, alright, to the upstream, under the bridge, and also the downstream, okay, depth of flow. So now we are going to analyze this, alright. So when B2 is 4 meter, and B2 is less than B max when you compare it, because B max is 6.65. So what case is this? Anyone can help me? Which case is this? 1, 2, or 3?
Case 3.
Okay, case 3, right? So this is case 3. I don't mind you want to put 3 like that. It doesn't matter, eh? Okay. So it's case 3. So case 3, you still remember, right? For case 3, right, you are going to get something like that. Okay? This is Y1, this is Y2, and this will be Y3. Okay, Y3 will be supercritical, Y1 will be subcritical, Y2 would be critical. Okay, alright, you're going to get like this. Now, this is a case of constricted width, so I don't have this weird thing, so it's actually flat only the width changes, right? So bear in mind, okay, there's no weir in this case. Alright, now for case 3, we know that this is case 3, so I'm going to draw out, the EY curve. Alright, I'm going to draw out my EY curve. So if this is my E naught, okay, case 3, my EY curve will be like that, because for case 1, my EY curve is like that. Case 2, the E mean will fall exactly on E naught. This will be case 3. So for case 3, okay, the thing that I need to know would be, once I have know this critical point, remember this is a control section. Once I know this value, I can actually find my E13 new, and I can actually find my, this is where my new Y1 is. I can read it from here. My new Y1, where is it? And my new Y3, where is it? And this would give me my Y2, which is in critical state. Okay, so what are the things that we know here? Can I get my discharge? Can I get my YC at this point? Yes, we can. Since we know that Q2 would be equal to Q divided by B2, right? I have this value. Okay, I have Q and B2. So my Q is constant, which is 18.6. And my B2 would be this B2, the new one, 4 meter. 4. So therefore, what is my Q2?
4.650.
Okay, 4.650. Okay. Okay, so meter ni. Okay, meter cube or second over meter. I have Q2. Once I have Q2, I can get my YC2. Okay, so my YC2 is Q squared G 1/3. Okay, can you help me with this?
Satu 301.
Alright, 1.301 meter. So once I have, now I know this value is 1.301 meter already. Okay, so once I have that, I can, now I know if you get this correctly, right, okay, your y1 should be greater than this value and your y3 should be less than this value already. Should be, okay, should be like unless, right, unless your point is like that, okay, but just be careful, right, this is just hint, okay, not exactly, all right, but this is just a guide, okay. Now, once you have YC2, okay, can you get E mean? Because you know that this E mean will actually give you the E naught, right? Sorry, the E13, the new E13. So my E mean at 2, alright, would be 3 over 2 of YC2, which is actually 1.5, times 1.301. So this would give me
1.952.
okay, thank you. All right. So I have 1.952 meter. So once I have this, then okay, at B equals to B naught, that means when B equals to B naught, that means at this location, B equals to B naught, okay. My E13, that means this guy here, alright. My E13 mu1 is equal to E min 2, which is 1.952 meter. Okay. Once I have that, okay, can I find Y1 and Y3 mu1? Yes, I could. I could find this value, this value already, so which is the sequence depth. I could find those. So I'm going to write this plus. I could, okay. So now, okay, square over GY13 square. Now, can I ask somebody which Q should I use here if I want to find Y1 and Y3? Should I use Q2 or should I use Q0? I have Q2 and I also have Q0 here. So which Q should I use? This one or this one? Because I want to find my Y1 and Y3 here.
Q9.
Yes, correct. So this should be, so you have to be extra careful when you are using this. So this is Q0 because you want to find Y1 and Y3. If you want to find Y2, then you need to read on this curve here, right? So I have this one equal to 1.952. Okay. So I'm going to substitute this. So this would be 2 and 3 to square equals to 1.952. Okay, now you know the other day, right, before our break, right, I actually share with you on how to use calculator. If you can write this in terms of cubic power, then you can solve for 2 solutions. So you want to try it now? I'll give you a few minutes. Try it. Give me Y1, okay, and give me Y3. Okay, could you please? second. Yes. One is correct. Okay. I'll just give you the answer here. You're right. Okay. The other answer that you give me, Hamizah, no, 1.3. No, the other one should.
0.425.
Okay. Something like that lah, correct? Okay, you're right. You said 425 kan? Yes. Okay. You're going to get something like this. So, you know that Y1 should be like in subcritical, Y3 should be in supercritical. If you look at this, one is greater and less, right? Now, Hamizan, just now you give me answer of what y, the other y is equal to 1.3. If you substitute 1.3 into this equation, right, you would not get this answer, no? Okay. But if you substitute this into this expression, you are going to get this. And if you substitute this value into y, alright, you are going to get this value as well. Alright, so that is how you check out basically. So you have to try out again, okay? Try out again how to solve the problem. So just now siapa yang bagi saya jawapan ni Awati ya?
Yes, Doctor.
So it seems like Awati has she knows how to solve this, so anyone can contact her and ask her to teach how you are going to solve for two answers, alright, using calculator. She can solve it very fast. Okay. So you have that. Awati belajar dari mana ya? How did you solve this?
Dari May17.
Okay, so you can ask from Maisato too. So half of you can ask from Maisato and half of you can ask from Awati. Okay. Okay, thank you. Alright. So that's solve it. Okay. Now, so we have solved for y1, y3, and what is y2? Y2 is equal to what? Y2, it should be yc2, right? Remember for case 2 and case 3, right? Y2 is in subcritical, is in critical flow, therefore it should be equal to yc2, which is 1.310 meter, which falls on this curve here. Okay, so this is 1.301, so you are going to have, this one is 1.872, the other one is 0.4, 0.4247 meter. Okay, Maisato belajar dari mana nak selesaikan Y1, Y3? Maisato is not there.
Hari tu doktor dah ajar.
Oh, ada yang guna YouTube tu
Yang lepas tu yang masa lepas kelas tu yang doktor cakap ada budak sebelum ni cuba buat macam yang dia darabkan kanan dengan kiri.
That means this, let's say you have the expression kan,
2.325.
So ini Maisato
Selesaikan 2.325
dapat berapa ini?
2 darab 981 tu.
Ini dapat berapa?
Saya dapat 0.276.
Kosong ya? 276? Ada nilai lagi tak?
0.276.
6 kosong ya?
276
Okay.
per
So
276. Oh, sekejap.
sebab 4 angka berarti kan? So ini betul
Sekejap ya.
Tak apa.
0.2755.
Okay, 55. Thank you. Ini Maisato kan? Okay, so like the YouTube video, right? You have to write this, right, in terms of y to the power, y to the cubic power, right? So this would be, that means you times both sides with y squared, okay, we times both
Doktor,
sides.
sorry, line saya slow.
Oh, tak apa, tak apa. Okay, we times with this both sides with y squared, you are going to get y cubic power plus 0.2755 equals to 1.952y squared. So you can rewrite this as 1.952y squared plus 0.2755 equals to 0. So this is how Awatif and Maizatul solve kan? Betul? Dengan calculator?
Betul, Doktor.
Okay, good. Okay, so you guys can try this out using, I think I shared the YouTube in the our last class before the break. Okay, so you may try this out. Okay, once you have that, okay, let's look at the third part.
Betul, Doktor.
Ya saya. Betul Okay. The last part is if the water depth just upstream of the proposed bridge is limited, that means just upstream is y1, okay, is limited to 0.2 meter higher than normal depth. That means 0.2 meter plus. Why not? Calculate the channel's width under the bridge. So what would be the B2? The question says. Okay, what is B2? Therefore, okay, Y1 is fixed to plus 1.2 lah. Okay, so okay, you want Y1 to be 1.4 meter. What does this mean? That means now you know what is this case, right? Because case 1, case 2, Y1 does not change. That means Y1 maintain. But case 3, in case 3, Y1 increases. That means this is in case 3. That means you are going to expect your B2 is less than B max. Okay, so I'm going to draw this out. So I wanted to know, okay, what would, what are the things, alright, is that I can get from this curve here. So I know that, okay, now my mu y1, alright, has already increased, okay, from 1.2 meter to 1.4 meter. Okay, actually you can check, this will be in subcritical. When you have YC naught, when you find YC naught, you compare it with Y naught. Okay, you are going to realize that this is subcritical, and that this is here, not here. So you have 1.4. Okay, so now you know that your this one, your E13, okay, the value of E13 will give you, is the value of E13, you can get it from when Y1 equals to 1.4. So E1, okay, let's just put E1 now, is equal to Y1 plus Q squared over 2GY1 squared. Now, this Q here is actually Q naught, because the Y1 here is actually from this line here. Okay, so E1, so I'm going to put Q naught here, is 1.4 plus, it's not like Q naught is, what is my Q naught? Oh, 2.325 squared over 2 plus 9.81 plus times 1.4 squared. So my E1 is, and can anyone help me solve this?
1.541.
Okay, thank you. So you have that already. Okay, so actually this is the new E1 lah. Okay, so once you have that, so I have this value. So this E13 actually is the same as my E min here. Okay, my E min here. So E min 2 equals to E13. E1 prime equals to 1.51 meter. So therefore, okay, once I have E min, can I get YC? Yes, I could get my YC2. Okay, so my YC2 is actually 2 over 3 of E min 2, which is 2 over 3 times 1.541. That means that would be how much? You guys are tired already.
1.027.
Okay, thank you. Semua getting eh. Okay, once I have my YC, I know I can get my YC. You remember this? You have YC equals Q squared over G 1 over 3, right? So I can get my Q. And Q2 is, alright, G1 C2 cubic. Alright, so this would be 9.81 and somebody is joining. Okay, so this would be YC cubic hour. Therefore, Q2 is, I'm just going to write the answer here. Okay, now. So therefore, once I have Q, I'm going to get my B2 already. Okay, B2 is Q over Q2 is 18.6 divided by 3.260, therefore it's 5.70 meter. As expected, right? This is less than 8 meter, which is our E0. So therefore, this is actually the width, alright, that is expected lah, alright, for question part 3. So I think by now, right, you should realize that, you know, all this formula, right, I don't really memorize all those formula. Well, except, you know, all this, right, will be given, right? Okay, but as long as you know the concept, okay, of this specific energy curve, you should be able to solve this. If you look at, you know, all those formula, I don't even look at, you know, those diagram, right, when, you know, there are 6 or 3 cases of that diagram, there are formula, right? So it's just that, you know, I don't really go and memorize all this formula, basically, okay? So it's just that once you understand this concept, it's fine. Okay, now, actually, I'm going to start chapter 4, but it's already 1 hour, so I'm going to start chapter 4 this Thursday. However, okay, the other day, somebody asked me about project, right? Am I right? May I know who asked me?
Yes, doctor.
Who is that?
Indrajit.
Indrajit, okay. I'm going to explain about the project now, okay? So, give me some 15 minutes before we end our class today. I'm going to explain about the project, the concept. Okay, now, have you taken a look at the video, that YouTube video that I've shared about how to determine the type of drain, the interceptor, you know, you have this berm drain, bench drain, interceptor drain, the toe drain, all those have roadside drain. What else? Shoulder drain. Have you looked at the YouTube video for the project?
Yes, doctor. Already watched it.
Okay, you watch it. Okay. Now, you actually have 2Q, which is the rational. Is this formula correct?
Yes, doctor. But divide with 360.
Do you know why need to divide by 360 and whether this is correct?
Uh, actually, I just follow from the notes.
Okay, let me tell you this. As an engineer later, right, you have to understand this. This is correct if the unit is meter per second and this is meter squared. This will be correct because this gives you meter cubic over meter cube over second. This will be correct, the formula. But do you realize that your I in that formula that you said, you have the other formula which is divided by this, right? Because your I is using millimeter over hour and this is you're going to use hectare. Am I right? So since you are going hectare and millimeter over hour, this give you meter cube over second if you divide it by 360. But if you are using I meter over second and A meter squared, you don't need to divide by 360. You know that? This is just a conversion constant. When you use the unit of rainfall intensity in millimeter per hour and also your area, catchment area in hectare, you divide by 360, you convert those units into meter cubic per second. Okay, let me ask you, Indrajit, may I know what is 1 hectare equivalent to? What is it equivalent to meter squared for 1 hectare? 1 hectare is how many meter squared? Anyone can help me?
10,000.
Okay, great. Okay, 10,000. How about 1 millimeter is equal to what? How much? How many meter? Tell me 1,000. Anyone, please?
.001.
Correct. Okay. So what I'm going to write is I'm going to write 1 meter here and 1,000. Thank you. Okay, it's like that. But you are right. It's 0.001. Okay. Now I'm just okay. How about 1 hour? 1 hour is equal to how many seconds?
3,600.
Thank you. Okay, you have those. So, okay, now I have. Here's the thing: there's no unit. The constant, the land use coefficient, no unit. Only I and A has unit. Let's check this out. Okay, I have I, A. Okay, the dimension would be in millimeter over hour, and then I have hectare. Alright, those are the unit. Okay, the unit. Alright, not the dimensional unit. Okay, now I want to convert this guy here. Alright, so I'm going to have, I said 1,000 millimeter will be equivalent to 1 meter. Then I said, oh, sorry. I should, because I want to cancel millimeter. Okay, now let's do this again. Okay, so I have 1 meter divided by 1,000 millimeter. This is the same thing, right? Okay, this will be equal to 1, right? So I'm going to times 1 millimeter here. This guy, Okay, so I'm going to cancel. Okay, the thing will change to meter. Okay, so I'm going to times, 1 over 1 hour. So I'm going to cancel 1 hour. I'm going to get second. So this will give me 3,600 second. Okay, so I'm going to cancel hour. Oh, give me a second. I'm going to cancel millimeter. I'm going to have meter here. Alright. So the next thing I want to change is I have 1 hectare. 1 hectare, I'm going to cancel it out with 1 hectare with 10,000. Alamak, okay, meter squared, sorry. Okay, now, so I don't have hectare already. I only have meter squared. Okay, now, look at this, I have 10,000, I cancel 1,000, I cancel 1 0. So the only thing left is 360. So therefore, I converted this 360. This unit becomes meter cubic over second. So now you know, right? If I write this formula is correct too. If my intensity I'm using in meter over second and my area I'm using in meter squared. But of course, the rainfall intensity that you are going to find is in millimeter per hour. Okay, you don't have to convert because if you are using this conversion constant, right, it automatically is convert to meter cube per second. Alright, so therefore you have this formula. I normally just remember this formula because I know that division by 360 is just to convert, alright, the unit. So I just divide by 360 lah, alright, if I'm using this unit, okay? I hope you are clear, Okay, now, this is just, for you to understand the whole formula. Now, there's another thing that I want to ask. Indranjit asked me about the flow. What is the A that we are using? Here's the thing, you have this manning. Okay, this would be Q of your drain. You also have this Q of catchment, which is, let's say you divide by 360. By now you should know what's the use of division by 360. I normally just put CIA. Right now, you have these 2Q. Okay, here's the thing, this would be, let's say you have a hill, bukit, satu bukit. Rain falls, so hujan lah. Okay, right now in Paraja it's raining, so it's raining now. Okay, it's raining. So when the rain falls on this hill, right, you have this separation point, the highest point, where, of course, whatever rain drops, it will go from highest point flowing to lower ground. Okay, so we have like that. Okay, so let's say something like that, it's going to go like that. Then if the water keep filling up, okay, you have water filling up, then you are going to have water overflow. Okay, now, if I'm going to build a drain here, I'm going to put a drain here. Let's say this is a, drain here. Okay, this drain, okay, the capacity of the drain, of course you are going to have some, pre-bought. The capacity of this drain, how you are going to determine it? You are going to use manning for the drain. How much water will come in? Is this much? That means, or including this area lah. That means whatever water falls onto this area, okay, is, look at this, the area of the land, alright, including all this, when water falls, times the speed of the rainfall. Okay, that means the intensity lah, rainfall intensity times land use. Now, what is the use of land use? Imagine the whole area, you have paved it. That means you put concrete. You put concrete on it. That means no water is going to seep into the ground. That means this is almost 0.9 or higher, 0.95. That means, okay, let's imagine if C is equal to 1. That means you only have I times A. How much rainfall falls will go into this drain. Okay? But normally, okay, it will get slowed down, you know. Even if it's paved, right, you are going to get some water stuck, all right, in, you know, some depression or things like that. So it's normally is less than 1, this C. If this is grass, okay, you are going to get values such as 0.55 and things like that. That means less water going into this drain. So therefore, if you ask me what is this A, this A would be the area draining into this drain. And what would this A be? This A is this flow area in the drain. Okay. So far, Indrajit, are you clear about this?
Yes, doctor.
Okay, now, you have this map, right? Okay. Okay, this topo map that I've given you. Okay, look at this. If I've given you this topo map, I'm going to draw something like that. So this is, let's say, this is idealized, simplified one. This is 450. This is 30 meters. So this is high ground. So I'm going to have, you know, another. This is 60. This is 50 meter. Okay. So I'm going to have, you know, I'm going to say I'm going to have a drain here. Drain. So now, if you ask me, actually you have to look at both sides lah. If you ask me, how much water or A you are going to consider, the A of catchment, the catchment area. Because the A for manning, you are going to get it from the cross section of this drain. Okay. For rational method, what is the flow? What is the catchment area? Look at this. Imagine this is plan view. Imagine rain falls on this area. This is the highest point, right? So you will expect, you know, your runoff would be like that. Everyone agree?
Yes.
Okay, so your sorry, the arrow. Okay, your runoff will be like that. So how are you going to estimate the area? So imagine that if this is going to at the end will fall into let's see. That's why you are going to determine the slope of the drain. See which direction it flows to. So this will go into here. This will go. So you can actually draw something like that to get. This would be your area. Now, if you ask me if this flows in, then if you look at the topo, right, this is going down. Sometimes you also need to look at whether the upstream area would contribute to this. Then you have to estimate further. It's not as, you know, simple as that. You actually have sometimes, right, in our survey plan, they only give you, you know, up to a certain boundary. You don't know what happened, all right, upstream, further upstream. Therefore, what you need to do is you need to go on site to survey what are the areas here. If there's a pond, then you are safe because you know that the water could be draining there and here. But if this is higher ground, then you need to cater some more. All right, you see, that means the water cannot go to further upstream, but you eventually end up in this drain. That means you have to add some more area here because this area actually contribute to your this rational method as well. If this A is greater, that means your Q will be higher as well. All right, provided the I is the same. All right. Now, I hope you are clear about that A. There's another thing that I want to explain to you, which is TC. Okay, it's just 5 minutes. Time of concentration, TC. Okay. If you look at this Urban Stormwater Management Manual, right, or MASMA, Manual Saluran Mesra Alam Malaysia, TC is equal to T0 plus TG plus TD. It doesn't matter lah, it could be T0 plus TD plus TG. So I have here, so TC would be time of concentration. It actually gives concentration. It actually tells you something about the name, alright. Okay. I'm going to draw a simple catchment. So this catchment, right, okay, there's a river, it will flow downward, okay. I already determined that this is the highest point, that means when rain drops on this plan view, right, whenever rain drops at this area, it will flow elsewhere, but whenever rain drops within this area, it will eventually end up at this lowest point. This is the outlet. Alright. Actually, when you're the engineer, right, you need to delineate this catchment boundary. You need to determine this catchment boundary. I'm just drawing a typical catchment area. So this is the lowest point. Whenever rain falls, it will be drained out at this outlet point. Okay. So now, what does it mean by time of concentration? Okay. Okay. Imagine this area. All right. This is let's say a natural area. You have a river. Okay. But there's no gutter, right? No gutter. That means your TC would be T0 plus TD. Okay. No gutter. Because normally gutter is when you have, road gutter and things like that, right? Okay. Now, I'm going to draw a hydrograph here. Q. We find, my point would be, okay, when rain falls, the first minute, right, you imagine part of the runoff will be drained out from this outlet. Okay, now this Q is Q outlet, Q outlet. I will tell you why you want to find Q outlet. Okay, when you design a drain, right, you wouldn't be designing, a drain with small size, then increase size. We know that so far, right, from our observation, the size of the drain is standard. Okay, so which part would have the maximum Q is this the most downstream part. It will get Q max. Okay, so therefore the size of the drain, of course, you want to make it standard size. You are going to get the maximum based on the Q max. So just make it. If you order sizes of drain, different sizes, right, the supplier will be having hard time, right, to comply with your demand. So just order standard size. All right. So therefore, okay, looking at this Q outlet here, right? Okay, the first minute, only the runoff will only reach this point here. All right, all this point. It hasn't reached this point, so I can plot out my Q is only here at the first minute. I say, all right, Q certain Q lah, Q1. Okay, then second minute, all right. This if the rain never stop, if it rains continuously, all right, then you are going to have more runoff reaching and then more runoff coming out already. So higher runoff. Okay, then after that, okay, when it reached TC, right, time of concentration, the minute, that means all the runoff has concentrated at the outlet already. say the rain has not stopped, so Q is coming out from this part, and you have the furthermost Q already reaching this point. So you are going to get, you are going to get Q something like that. When it reaches the time of concentration, right, all the runoff will keep coming out non-stop, and you get a Q constant already. This is when, right, all runoff concentrate at the outlet. Just the name, the time of concentration, where the time is the time needed for all the runoff to concentrate at the outlet. Okay, so therefore you get this here. The point is you want to get the Q maximum because you want to make sure the design of your drain is sufficient to cater for Q max or peak flow, basically. Yeah? So therefore, you need to determine the time of concentration. Now, when you read the manual, right, it will say the furthermost point to get this time of overland flow. Furthermost because they want to know what is the maximum time. So, for example, right, there is one point, right, which is very far to reach here. So, by right, it has already catered this all the time needed for the furthermost point to get to the outlet. That means by now you should know all these are coming out already, to get at Q max. Now, do you need T0 plus TD? It depends. If you can get T0, for example, the time needed to flow out here is longer compared to T0 plus TD. That means the time in drain flow, then you have to take this time here because it's longer. That means when it's longer, you expect this runoff has already come out. Okay, so that's the point lah. Actually, I want you, the concept would be the time needed for all the runoff at every point within the catchment has already reached the outlet. So I hope you are clear with this explanation of the time of concentration. So are you guys clear? I'm going to stop now because you probably are too tired already for this during this 1 hour. So I'm going to stop this. So do you have question? Guys? Semua dah penat
Ada doktor.
Okay. Because this is your first class after you come back from your long break, so I'm going to stop here. We'll continue our chapter 4 next Thursday morning. So I'll see you guys Alright?
Okay, Doctor. Thank
Alright,
you.
take care, bye-bye.
Thank you.
Thank you, Dr.
You're welcome.
Thank you, Doctor.
Thank you, Doctor.
Okay.
Thank you, Doctor.
You're welcome.
Thank you, Doctor.
Thank you, Doctor.
Thank you, okay.
Alright.
Thank you, Doctor.
Thank you, Doctor.
Alright.
Thank you, Doctor.
Thank you,
You're
Doctor.
welcome. You're welcome.